Hello, everyone, and welcome to today's webinar, How YouSolar's Technology Succeeds the Solar Industry Market Leaders. Here today to give a presentation is Dr. Arnold Leitner, founder and CEO of YouSolar.
Good morning, everybody. Welcome from California. My name is Arnold Leitner, and I'm the founder and CEO of YouSolar. And the title of today's webinar, as Baxter introduced me, is How YouSolar's Technology Succeeds the Market Leaders, Enphase and SolarEdge. And we put a little challenge up with a tongue-in-cheek by showing a picture of the black swan, a black species of swan from Australia and adjacent island chains, which was a surprise to European voyagers who had assumed there would only be a white swan. And so it's become a symbol of the tech industry for a sudden surprise, a disruption of a market. And I hope by the end of the webinar, you agree that we chose that symbol nicely and wisely. So with that, let's move on and tell you what YouSolar does in a few words, and then dig into the topic of today's webinar. So YouSolar, apologize, one back, makes the power block solar nanogrid. And specifically for our company, we started the design of the technology by combining both the solar array and the power unit into a functional system. So most of the time when you are looking at a solar battery system, they call it, you think of the power unit, also known as the battery, which isn't really just a battery. Just like a gas can is not a car, it actually has many other functional elements and power electronics, charge controllers, or an inverter integrated. And in case of the power block, it also has the solar input module, a rectifier module that connects both to a utility power or generator power, and at the same time, and other components. But unlike almost every company out there, we believe we're the only one that looked at this from the very beginning as a one unified system that also includes the solar array. Most people who offer a battery system started with that and added a solar system to it, or came like Enphase and SolarEdge with a solar array technology, power level electronics, and panel level electronics, I should say, and added that to a battery system and try to make it all work as a nanogrid. Our view had always been that you have to do both at the same time because they're functionally integrated. And here we are looking at the STEP solar array, and it will be the focus of today's webinar. We try to understand, explain to you how the STEP solar array is different and how it enables the functionality of the power block. So again, we are merging the solar array and the power unit into one functional system by design of both of that working together. So here's the solar array, panels on a roof. You're familiar with that. And we're going to zoom in here on one of those panels and look very closely and briefly put on your propeller head. It will be to your benefit. I'll try to make it as easy and simple as possible. I created my own graphics to kind of make it unified and clear. But for here and there, you need to just go along and just be an engineering nerd for a moment. So let's look at an individual cell in that panel, and you're looking at something that's about this size. You probably imagine those wafers, maybe you've held one in your hand at a trade show, and they're not exactly 0.5 volt electric potential and not exactly 5 watts. Sometimes a little higher, both numbers, but it's a good way to remember. So, 0.5 volt and 5 watt. So that's not much voltage and that's not much power. So what you need to do, you need to add them together and connect them to make a panel. And that's what you do. And I'm choosing here kind of a current modern panel size, about 380 watts. The industry has been going up in size for very good reasons. And if you string like 72 cells together, you end up with about 40 volt and 380 watt using the precise numbers of the electric potential and power of each of those cells, which I kind of ignored earlier for simplicity. So you can go from left to right, you just add those all together, you jump down the road and so forth, you go and you get 380 watts in a solar panel, and you literally adding up those half volt plus potentials, and you get to 40 volt. So how do we make a solar array out of it? Well, the most obvious idea is that you just put them all in parallel, and the current comes down from the panel, and it's additive. So what you end up, if you combine 10 panels, and I chose that number with some foresight, you will have a situation where you have the same electric potential at the end of this line, they're all 40 volt, but you have 10 times the current. So, almost graphically, I try to suggest that's a little unwieldy, a little bit unreal, impractical. Not that it hasn't been done, especially specifically in off-grid systems, but that's not the way to move forward. What you want to do, and it takes about a moment for anyone in the room to say, we want to connect those in series. And this is kind of what it looks like. Again, the current runs through every single wafer and every single panel, up and down, and then down at the bottom, into next one, up and down, and so forth. So, and again, you're choosing 10 panels, which is, again, the kind of standard for a string. And so you end up with what we call the string array. And the advantage you have now is that you have the same current running through every single wafer, every single panel. Kind of hard to imagine, but yes, that's what happens. And but you're up 10 times in electric potential, 10 times the voltage. And that's a good thing. Let me convince you just by stating it as in that high electric potentials are good for you. It makes your life a lot easier, makes things smaller for your electronics. So that is the standard string array. And typically, it looks like this. That's kind of how I graphically understand it. It's the original solar array, about 10 panels. And remember, we had 40 volt per panel times 10. You get 400 volt. Ouch, that's getting also a little bit dangerous, right? Especially if you can't turn those panels off. If you have to throw a blanket on them or pray for rain for them not to produce 400 volt. So there is some caution here involved in connecting a string array before you and when you insert it into inverter. And so again, you have the 10 panels, you step up the electric potential to 400 volt, you have the same current running through them. We'll emphasize that shortly. And that goes into your string inverter. That's the classic solar inverter. And I'm showing you a very good product by Fronius. That then produces your AC power. That is your traditional solar array. Now, we already pointed out some problems. You have to deal with 400 volts of high electric potential, which can be a hazard to installers if they don't do their job well and correctly. But before we go and look at some other drawbacks, we need to learn one equation, and that is that the current multiplied by the electric potential, also the voltage, also known as the voltage, is equal to the power. Now, earlier I showed you the power and the potential of a panel. So that's, the equation we need. So if you divide power by potential, we get the current. And that's a number we're going to use here briefly. I'll show a number and then get rid of it later. But let's take a look and solve that equation here. So again, we're back at the string array. And as we discussed, it runs the same current. And now just to make it a little bit illustrative, let's ask ourselves what that current is. And, it's pretty simple to calculate. 380 watts divided by 40 volts. That's 9.5 ampere. And again, we noted earlier, that same current runs through every cell, every panel into the inverter. That's all good. That's how on a sunny roof, everything works. The panels are equal. If the sun shines on them equally, if they're, this is how it works. This is the perfect world. This is a wonderful array. And in fact, practically, it takes you very far. Now, there's 9.5 volt going into the inverter. That's all what we expect. And we're good to go. So the problem is it's not a perfect world. You have what I just termed, to be clever, the 3 C's of the string array. You have clouds, you have cracks potentially in panels, thermal cracks, mechanical damage, people on the roof, branches falling on the roof during a storm, and you have crap that could typically is dust or rain rings, or also, some environments could be bird poop. And so that affects the panels, as you just intuitively can imagine. So let's ask ourselves, what is the impact on those? Bear with me, or just believe me, the electric potential, the kind of charge difference that's built up in the cell, is not much affected by these. So they're pretty much all operating still at 40 volts. But what changes is the amount of current they can deliver for each individual panel. So this is right now is a look at each panel. And so I highlighted in yellow. So a 9.5 ampere that earlier described the perfect panel under full sun kind of got reduced, for the cloud, which is saying it's down half. The correct panel, we say it's like 7 amp, only maximum. The panel with the crap on it, the dust, is about 8 amp. So the question would be to all of us, what happens, right? We said earlier there's a common current. So what is the result on the output of our inverter? And I simplify some things here, and those who are electric installers and solar expert know that I'm overlooking something called the bypass diode. Just allow me just for explanation to kind of simplify it. But let's assume this is what we're dealing with. What would be the outcome? So what is the ampere? What's the current going into our inverter? We're still at 400 volt. Each panel still we set 40 volt, so that doesn't change. So what's the current? And what we said earlier is that there's a common current running through all panels. So it must be the current of the lowest performing panel. So the 4.75 amp of the clouded panel dictates and dominates all other panels. It is often referred to as this Christmas light effect. That's a poor analogy, but you've heard that term, and that's what they kind of were thinking of. It's just not exactly that way, but you have that reduction of current. And what it means is, shockingly, even though only one panel is really down half, the other one, two of them are a little bit dragged down, your entire solar output is down 50%. And that made people ask themselves, is there a solution to that? And two companies came up to date with a solution. And the first one is Enphase, that I'm naming. I don't know exactly which one developed the product first, but Enphase, very importantly, a very dominant company, accounts for like 80%, I believe, of residential install, invented the microconverter. What does that mean? Apologize, I should say the microinverter. My apologies, everyone. I'll correct that after the webinar. So it's a parallel array again, and it puts the inverter on the solar panel. So what it means is they go back to the parallel array, but this time it's called an AC array, alternating current array, and the micro inverter is attached to each panel. So here's the micro inverter here. Let's forward here. There you go. And what it does, it steps up the electric potential from the 40 volt of the panel up to 240 volt AC, and the volts are up and the current is down. And now you can do this parallel array. You don't have this enormous stack of current that we showed earlier at the very beginning of this webinar. So this is what they did, and that's very clever also, because they got rid of that central inverter, that we saw earlier on the string array. They, put it up on the roof. Now that's not without challenges. These micro inverters are a very delicate piece of electronics. They're extremely well designed, but they had high failure rates, and to this date they are not as reliable as a string inverter from that sits in the garage, not exposed to the heat, and other power electronics that are not as sensitive as inverters. But the success, I think, proves them right. It made installation of the system so much easier. And let's take a look now what it did to the clouding problem. We're simplifying here the situation and limit the shading just to the cloud here on one panel. And we ask ourselves, what's the impact on the current and the power? So we have a 50% reduction in this panel. Remember, we said it was down, it was a 40 volt panel, now it's down to half the current, so that's down 50%. But what's the result on the overall output of this array? And again, you will find 10 panels in series. That's the maximum of microinverters you can string for the 380 watt inverter that I'm showing here and summarize in a moment. So you have 50% power down in one of 10 panels, okay? That means it's only 5% down for the entire 10 panels on this parallel branch of AC microinverters. So we really addressed that shading problem, and that kind of was the success of, or at least the marketing success of Enphase. And it helps installers in kind of commensurate situations where they have panels on the roof in different orientations. Let's say I just choose randomly south and southeast because it kind of makes sense where you would put panels. And although they are in different orientations, all panels act independently. And so, you really don't have what's called a kind of a mismatch problem in terms of illumination of the panel, which can result in, again, different types of currents. So check mark for SolarEdge, for Enphase, it resolved that challenge as well. Now, here's the IQ8H. That's the flagship or the largest high power microinverter, 380 watt. I apologize, at 240 volt. You can have a maximum of 10 inverters per branch, which is a 20 amp circuit. And it saves the central inverter like all Enphase products. It provides panel level data. That's again something the string array doesn't tell you, how much each individual panel produces. It also provides rapid shutdown. If you recall earlier, once the strings are connected 400 volt, they're at 400 volt. There's nothing you can do. You send a turn off signal to the Enphase IQ8H, and it will stop producing, and there will be no electric potential on that home run cable. You can principally also use different panels on the roof because it doesn't matter, because really each panel is its own solar array, if you like to think about it that way. And again, different rotations, which is kind of similar to the shading issue, are not a problem for the microinverter. So that was one solution. But then SolarEdge came back and said, oh, we got something simpler, hardier, the optimizer, another way of doing it. And what SolarEdge said, let's say with a string array, it's a kind of nice thing to stack up electric potentials. That's kind of easy, cheap way to get up to efficient inputs to an inverter. And we just optimize the production of these panels. And I will say that what I'm going to show you here is a gross simplification. The math is actually kind of tricky. It's easy, but it's beyond what we can do today. So let's just go back here and say we have the string array. We added these optimizers. And the way I want to think about you is that it's kind of hard visually because of the wires going up and down, right and left. But think of those black optimizers to be the panels now, and that there is one horizontal line combining them in series. So they're not in parallel. So it's a wire going in and out, just like the very original drawing I showed you of the string array. And so they still have the same problem, right? If one of the panels is shaded, here's the the optimizer, then what's the power, right? Because we still have to run the common current through the system. So what these Enphase optimizers do is, remember, power is a product of the electric potential and the current. Okay, if one of the panels can't produce the current, can I not just work with that? Can I drop its current, its voltage down and bring its current up, right? As long as I don't violate the fundamental law of physics, which is conservation of energy or conservation of power. And that's what they do. And it's not straightforward to understand, but in the end, what they're able to do is adjust the current of the lowest performing panel and change the current of the normal panels in a way that the overall impact is rather modest. So what is, sorry, I might say something working about my slides here, apologize. So what's the overall impact? It's 5% down, okay? So we have the same result as for Enphase. So now moving on, orientations, same advantage, really fundamentally the same, check mark, there isn't really an impact on the performance there. So this is a P370. It's a 370 watt optimizer. It's not exactly the same as the Enphase, the 380 watt, but it's close to it. You have a limitation here. You have a minimum of 8 optimizers per string. So you can't have a shorter string, or you have to go by multiples of 8 or more. You need to have the specific SolarEdge inverter to use. You do get panel level data. You do get rapid shutdown because that that optimizer again sits on the panel, will control what's coming out of it. You can principally use different panels, less so than I guess with Enphase, which is truly panel independent, and you can definitely deal with different orientations. So the summary of the benefits is that they're same for shading. Enphase it has no strings, 240 volt AC, and SolarEdge has strings, has 400 volt DC, which is good, but has communications. So the strings are a good thing is getting rid of those with Enphase. Having 240 volt is kind of not so good. It's kind of low electric potential. And being AC was great until you grid tied, but kind of becomes problematic when you want to integrate a battery, which is on direct current. For SolarEdge, you have a high electric potential. That's good. You're DC. Sorry, again, that's a benefit when you bring in batteries. You have strings, so you still have multiples of 8 or more. You have to accommodate. You can't just lay out a random array of, like, say, 17 panels. And you have communications you have to do because each of those optimizers needs to be told what to set its current and how to bump up or bump down its electric potential to do the magic that they do. So that's kind of a downside. So ask yourself the question, what if we could have no strings and 400 volt direct current? So what instead of a DC-AC microinverter that Enphase has developed, what about a DC-DC microconverter, where converter refers to DC-DC? It would have all the benefits, but would be directly compatible with a battery system. So that is the YouSolar microconverter. And I got the spelling here correct. This is a converter, not an inverter. And let's take a look. What is it? So here's a picture of the microconverter. The step, the solar panel comes in from the top, just like, this Enphase system. And then at the lower part, you see in red and black, that's kind of the home run cable, the parallel 400 volt, or in case of YouSolar, 380 plus volt direct current bus. Here's a product specification, just doesn't look any different from the other ones in terms of what we list. 380 watts, it's actually 380 plus volt direct current. There's a maximum of 30 converters we can put on a branch. That's 10 times higher than Enphase. That means 10 times less cabling. We do have a central inverter. You may look at this as a downside, but I will assure you in a moment that's actually a real benefit for a solar battery system. We also get panel level data. We have rapid shutdown for firefighter protection. The moment you press the emergency stop, all the panels turn off. We can use different panels, and we have all the same benefits of different orientations. So this is, the parallel DC array with the YouSolar micro converter. I'm not going to go through all the shadowing benefits. It has all of the same benefits. And we can have 30 of those in series. Why? Because we go from 40 volt to 380. So volts more up, current more down. So that's really a good thing. And that's why being flexible and able to increase the electric potential over 240 volts, which unfortunately is the limit of Enphase, because that's what the home is being supplied directly. We are not limited to that, so we can raise the electric potential to 380 volt, which is kind of a new emerging standard for direct current potentials. And if you look at a lot of products, including your EVgo charger, you'll see that they operate at 380 volt, not quite exactly 400. So is the step microconverter the heir apparent of this industry? So let's take a look here about how this now works in combination with batteries, because that is going to be a little bit a clue to where we're headed. So here's an Enphase system. You have the microinverter on the panel. You have all kinds of combiner box and electronic switchover devices, and you have a bidirectional inverter on the battery, which in fact is yet another microinverter with a lot of changes, programming changes. They're pretty clever. They're reusing that, but they have two inverters. So one on the panel and one on the battery. So kind of double up an expensive device because you need to get the power out of the battery, and you also need to get the AC power into the battery. They have no generator integration. On the website it says it's coming, but it's been coming for a long time. And there's a principal problem. It's very difficult to integrate a generator on the AC side, and it's pretty much not possible. The electric potential is fixed and capped at 240 volt, which is not as efficient for the overall operation of the system as 380 or 400. Very limited scalability. The Enphase battery is really just an energy arbitrage system, and there are many active controls, and the inverter power is also relatively low. Now, if you take a look closer, and I read some of the application manuals, and I kind of took a look and what are some of the footnotes in there. For example, if you want to be off-grid, you have to have a consumption monitor on every circuit, otherwise the ensemble doesn't operate correctly. if your total photovoltaic system exceeds what can be supported by the total end charge, that's a brand name system size, you have to split up the PV system. So, it is the reason why we have a lot of installers that are just mesmerized, excited about the product, because all these little footnotes that then disappoint your customer unless you give it a bare bones installation, they are all not applicable with YouSolar, and we'll discuss in a moment. Now, SolarEdge, again, we're seeing a picture here. You have the DC optimizers. They are in series now. You need a combiner box. It feeds the battery, which doesn't have a constant electric potential anymore. That's something they had tried to keep. You have the inverter, which needs to be the specific SolarEdge inverter. You have this backup interface where they integrate the grid power and then drive it to the load. And you have a string array with the DC optimizers. You have no practical generator integration, and I'll show it to you in a moment what that means. And for the SolarEdge system, and you have very limited scalability of the system, many active controls, and you have moderate power. You can get up to 30 kilowatt out of a Enphase SolarEdge system. I apologize, but again, I read the application manuals, and here's one specific regarding the generator integration because I was curious, and here's what I found. The generator must be able to support the entire load independently. So if you have a home with a 25 kilowatt load, you need a 25 kilowatt generator. That's a large generator. And then the solar system cannot exceed 35% of the maximum power produced by the generator. So really, I have a solar battery system, and if I want any generator to back up the system, I need one that's as big as my entire house load. And then, by the way, my solar system can only be 35% of that power. You can see why I call this non-practical, and I don't think anyone would integrate a generator into a SolarEdge. In fact, it would be opposite around. You would have a large generator would try to supplement some of the power with a SolarEdge battery system. Coming to YouSolar, the black swan, we have microinverter converters on the panels. We have a bidirectional converter on the batteries, which allows us to be battery agnostic and independent. And we have a powerful grid forming inverter, and we bring any grid or generator power in with a rectifier. And so again, the DC microinverters on the roof, any generator can be integrated. More than one generator can be integrated. Generators of different phases can be integrated. All the power blends seamlessly, and I had intended to cover this in this webinar. I decided it was too tricky, too complicated, too much, so I cut it out of the agenda. I apologize for those who are disappointed today. We'll have an additional seminar on this, how we use small changes of the electric bus, which is why I show it fluctuating between 380 plus minus volt on top, how we use that to let those components all do the right thing, independent of any really active control. And that's for an upcoming webinar. The result of this architecture is a highly scalable system. It's very high power. Currently, we do basically 10 to 100 kilowatt, but I'll show you at the end of the webinar that number is being demolished here in short order. And we can do a 3-phase or a single-phase inverter, or both on a power block, or multiple inverters in parallel. It doesn't matter. So we can really scale and adapt to whatever power needs you have. So there's no application manual for the power block. The answer is all modules are automatically detected. There's no combiner boxes or whatnot you need. And I assure you, you will run out of roof space and place to put the power units before you ever reach the power block's limits. So it's really all you want can be done with the power block, simply automatically by automatic scaling. So you can scale it up. Here's a larger power block, by far the largest. You can go about 4 times larger than this, and you still haven't fully reached the capability of the power block. This would be, for example, for a very large home, but you can go up to clinic size. It's multi-source, right? All of the sources blend seamlessly on the direct current bus. You can have solar, grid, generator, fuel cell, hydro, wind. It all integrates on the power block. Because the power block is always a grid forming system, you are at the same time on and off grid. There's no difference. Everything is plug and play. Here we're showing a step forward to our anticipated stackable module system that just gets rid of the rack, but otherwise it's the same good power block. And it's fully automated. We do call our controller the traffic controller, and reference to a traffic control tower, but it does so much more than even Enphase and Ensemble do. It's a smart controller. Not only does it do time of use arbitrage, but it also looks ahead at weather, calculates how much battery power needs to be set in reserve, and manages all the components, can manage multiple batteries of different charge potential, of different vintage, and so forth. So you don't have to think of anything. And also, what we believe is that the inner beauty of the power block is also expressed in its outer beauty. I know beauty is in the eye of the beholder, but I ask you to agree with me that the power block's user interface is graphically much more compelling than that of our competitors who've been doing this for decades, shows more information in a much simpler way. And I hope, if I can show you the power electronics, although I have one sitting behind me on that, you can see it in the corner, I hope that will be a sign how much attention we pay to simplicity. A fool can make everything complex. It's really hard to make something simple. And that's what we have tried to do with the power block. So the question you have is, great presentation, Arnold. Is it working? You bet it is. Okay, here's an example of a power block with a customer in a kind of a basement environment. And we have a couple of projects now operating here in California. We have 8 residential projects here. 2 have the Power Block 50, which was an original vintage design that proved a lot of our technology, but operates slightly differently. We have 4 Power Block 380 operating right now. That's our current standard design. And we have 2 in construction, meaning that most of them are like 80% installed. We just have to commission 1 every other week, since we're a small team, and we're going to go have 2 more left to do. And I think 2 or 3 weeks we're done with them. And so that's what we have operating here. We have multiple proposals outstanding. 1 is under contract, and then we have also many proposals outside the country, and 1 under construction in Florida. So what we do is, we combine the best of Enphase and SolarEdge. We have a parallel array like Enphase. We have a stable direct current potential, albeit it varies slightly around 380, and that's a good thing. For the inverter, that's a stable electric potential. We have panel level maximum power point tracking. That's kind of the whole shading and crap and crack issue I discussed earlier. We have rapid shutdown for firefighter protection, and we have panel level performance monitoring. All what these companies have, we have, but we have other advantages. We have unprecedented control in a battery nanogrid. Again, I apologize, I have to kind of skip over this today. I try to include this. It's just too much. We'll have this for another webinar. We have 3 times less cabling than Enphase, because we have a higher electric potential. Lower currents means we can put more on the existing cables. We work with any inverter, with the exception, of course, of an Enphase that is already an inverter, or SolarEdge, which needs to be specific to its panel, but pretty much everything out there in the world we can use. And we have simpler and cheaper electronics for a power array than Enphase. So who do we believe is the heir apparent? We think it's YouSolar. I think we deserve the Burger King crown in this industry, and we're very excited what we're going to do next. YouSolar succeeds the market leaders, Enphase and SolarEdge, in our opinion. My name is Arnold Leitner. I'm the founder and CEO, and Mike Allman is a director and investor in the company, and Galen Tornaby is our chief operating officer. And I just want to announce, I don't know why the slides got skipped, but we have the Power Block 600 coming out. It's a dual bus Power Block, 380 volt, 600 volt, that will have up to 800 ampere of current. So that's up to 200 kilowatt of power. And that's insane amount of power, and it's coming out probably in about 12 months. So we don't have much to do, but everything takes its time. So thank you for being on the webinar. I just want to point out we have raised over $500,000 on Start Engine. So if you're interested in investing in the company, please do so. Go to Start Engine and invest in YouSolar at startengine.com, YouSolar. And now I want to open it up to questions from you. So thank you very much. Please use have used the Q&A tab, and Baxter will show me some of the questions using the chat window, and I will start answering your questions. So thank you very much for joining this webinar, and we'll open it up to your questions. Okay, there's a question from Andrew. How the direct current from the solar panels affect the experience of the installers. So the micro converter will be down. It will be not operating any electric potential when it's not receiving a turn on signal from the controller. So as you plug it in, it's passive and it needs to get an active control, and only then will it bring up the electric potential. So in terms of installation, it has the ease of the Enphase system, or commensurate with the SolarEdge system, except you have 3 times less cabling to do. So for a typical home with a 10 kilowatt array, which is pretty large for many homes, you just kind of have one branch and one cable coming down from the roof. So Andrew, thank you much for that question. Okay, so the question is, 380 volt is great, or 400 volt is great. Why are we not going up to 1500 volt? Like a utility scale solar system. The answer is that 1500 volt is considerably more dangerous, and also many standards in insulation are and stop at 600 volt. So most components that you can get are at 600 volt, and a 1500 volt array would simply be too high electric potential for most components you can buy. I will also let you know, the benefit gain won't be there, because you will never string so many panels together to get up to 1500 volt. That would be for SolarEdge, and for Enphase, or for YouSolar, step up to 1500 volt, and then basically drop down back to the 240 volt of a AC of a home. That's actually an inefficient way. You will be losing some of the efficiency. That's different for industrial solar, because from the 1500 volt of the solar array, it's just going up from there. Right now it goes up to feeder to 30 kilowatt, and then a high voltage line, and then running down to the load center. So that's the reason. 600 volt is standard insulation value. And again, because you're ultimately operating at 240 volt in a home, there's really no benefit to going higher, much higher. 600 volt, yes, that's what we're doing, but not much beyond that. See another question from John. You showed a grid connection as simple rectifier. It doesn't mean it's one way. So the answer is, most of our customers do not want to be part of the utility system anymore. And also, when you offer a very large battery like YouSolar can affordably do, that on average has 24 hours of energy storage, you can get to a situation quickly. And if you also don't try to 100% supply the load, that, with a little bit of adjustment, you can achieve a self-consumption of something like 90%. So only 10% of the energy would need to be net metered. And so the overall electrons or kilowatt hours you're leveraging over the grid-tied inverter that you have to pay to purchase is very little. So it almost doesn't pay itself. So you just rather let those electrons spin and go unused. Is in principle possible to grid tie and sink, we call sink electricity down to the grid and bring it back to the rectifier? Absolutely, yes. It's very easy to do, but we haven't really found any customer that was interested in that. See, there's another question coming up. So what a great question. Well, all questions are great, but this one is good because I was hoping for it. What size electric system are you targeting? A residential, commercial, single phase, or 3-phase? So as I suggested earlier, and unfortunately for some reason, we had a little bit of problem with the slide progression today. I don't know why. What's trying to show you the PowerBlock 600. The PowerBlock 600 is able to provide 100 amp up to 800 amp power. It's a 100 amp module. You can have up to 8 of those. And that's a 200 kilowatt home. 800, and I would like to tell you that's not normal, but unfortunately with electric vehicles coming to home and electrification of the home, meaning people replacing gas furnaces with heat pumps, many of our customers soon, we are designing systems already for 300 ampere service. So it's regular residential 100 ampere. If you want to run a regular home, you have to have 100 amp or 200 amp. Most homes, as I showed the last presentation, last webinar, 200 ampere homes. The homes that we're doing are bigger, and there's really a big gap in the market. We can also do small commercial. Now, question between single phase and 3-phase. Most residential homes have single phase. That's also what the utility delivers. But we have worked with a home that has a 3-phase supply, and we can do both 3-phase and single phase. see if there's another question coming from the audience. Yes, so the question is, can the YouSolar system use all energy sources simultaneously? And the answer is yes, absolutely correct. So how do we do it and why? And the reason is, think about it. None of the components you saw, the battery or the solar panel, connects directly to the 380 volt high potential bus. They all have a piece of power electronics in between. And specifically for the battery, that piece of power electronics decides what the electric potential of the battery actually is. And it doesn't have to be 380. It doesn't. So each of these batteries, if you're multiple in parallel, we can set their virtual electric potential at 385, 383, 390. And we can also tell them how much they're allowed to charge and discharge. And so we basically create like a dispatch order, like traditional utility systems, where a small change in electric potential of the bus dictates what is being used. And how is that small electric potential being set? Well, it's pretty simple. An inverter pulls on the electric potential, it pulls it down. So if the load is high and low is low, apologize, the electric potential will slowly float off and will turn off all the devices that are not really needed or expensive to run. Say the electric potential floats above a level where the rectifier says, oh, I'm not producing any power. The bus floated up to 383. I'm only supposed to give power up to 382 volts. I'm stopping. And then as the load increases, drags down. Think of it like someone pulling, like a little kid pulling on your arm, like, weighing you down. Your arm kind of goes down just a tad bit. Then the electric potential drops because of the load below 381, for example, and then the rectifier starts blending in. You can decide whether you put the batteries above or below the rectifier. So, maybe you don't want any batteries to be used at all. Maybe it's really cheap nighttime power you want to run, and then the batteries will not discharge. So that's how we do it. It's small changes of that bus in an analog way, tell all the components what power to flood onto the bus. It's fully analog. The generator, grid, panels all running at the same time. John, so the question is our system competitive with Enphase and SolarEdge? And I presume you're asking about cost. The answer is we price our system to be competitive. And we also recognize that we do much more than these systems provide. If you need 100 or 200 kilowatt connection or soon more, you simply cannot go to these companies. And I'm not saying we're taking advantage of our customers, but we currently see that market really doesn't have a lot of challenges. So we don't have to be that price sensitive and competitive to really look over our shoulder all the time. But for the smaller systems, there's again a limit. We are a high power system. Are we competitive against a 5 kilowatt hour battery from Enphase with 4 kilowatt of power? The answer is no. Our system doesn't even go that small. So, but we are occupying a market where people want to go off grid or grid forming, kind of done with utilities. None of these systems by Enphase or SolarEdge can deliver the kind of power that's needed. And then they come to YouSolar, and we have so far found that our pricing is competitive. But we certainly will work a lot on our costs, and that's the goal for the next year. And the PowerBlock 600, for example, already cut our power cost significantly. So can Enphase and SolarEdge just copy what you're doing and keep their market share? The answer is not that easily. There's actually a patent that we have a license to, and we currently only license C, and it comes from our technology partner. And it protects the entire parallel architecture. It actually protects the microconverter as an idea. That is not true for the microinverter and for the optimizer. As you know, there were multiple companies in that sector. Beyond that, you have to first build a high performance microconverter. Ours have been tested for, I think it's now 20 years. We have runtime on them. There are other aspects of the system control and design that we have patents on. So also they would have to completely abandon everything they're doing, right? So yes, in principle, people can challenge patents, try to do something other people do, but it's been tried before, and it's not always that easy to kind of do a 180-degree turn and do something differently, especially when there are patents and IP in a way, and in our case, decades of experience with these electronics. So, okay, great. Can the YouSolar system work with a smart distribution panel? Have you tried integration? The answer is there's no reason why they wouldn't work with them. what are smart distribution panels? They're basically the idea is that you can drop load by sending signals from an application, often controls from a app on your phone, to drop certain loads. And the primary reason is that's done when there's too much energy in the system is in danger of running out of energy. It's usually not to drop power loads, because you definitely want to design your sub panel so that the maximum power of the sub panel doesn't immediately overload your battery. And I will just answer that, yes, it does. I mean, there's no reason. I mean, we are a grid forming inverter. Once you go into the breaker panel, which is coming in at any utility, you can integrate one of those smart distribution panels. The question although becomes, why would you want to do that? If I have all the power in the world, then I don't really have a sub panel. And if I have really very large competitive batteries, very competitively priced is what we can do with our design, then, I got 24 hours of energy storage. I have so much energy, and I designed a system with YouSolar so that I really don't run out of energy. I can have a small generator integrated. Why do I have to have megawatts at home, make my life miserable if I can just, for the same amount of money that the panel costs me, just run the whole house. So we kind of think that our customers will probably not be interested in that. I also will say that the traffic controller has this ability to also drop circuits. There are other companies out there that don't make as sophisticated panels, but we know and have found a discussion with companies that have done off-grid solar for a long time, you only really have to drop two or three loads to really take care of most of the problems. And we can do that with our controls easily. We haven't done it with the customer yet, but we have researched it, and we know we can do it. We're remotely starting turning off generators. So for us to control a smart breaker, which exists, or a contactor isn't that big a deal. So doesn't Tesla use a power block in the installation? If you're referring to the trademarks, they have the trademark Powerwall and Power Pack. I believe that's both are not trademarkable. Definitely Powerwall is not. But if it's more related to the technical question, using a power block in their solar installations, the answer is no, because the Tesla Powerwall is to some degree what the power block provides, except the power block does much more than that. For example, the Tesla Powerwall also doesn't allow for integration of a generator. It, at least last time I checked, it would have the same problems that Enphase has. Any AC integration of generators is very, very difficult and very limited. So no, they're not using the power block, which is our product. Let's see if there's another question coming in. All right. Okay, so the question is, Enphase has their smart switch, which replaces the automatic transfer switch and generates a neutral circuit. Okay, great question, great point here. So when you have, and this may be, a two propeller head here, so I'll make it simple, and maybe that person can follow up with me directly. The first question is, they use a smart switch to replace the automatic transfer switch. We are using right now third-party transfer switches to go back and forth just between the power block and the grid for situations where the power block were to go down. And we're really installing those in the first system so that we don't have to go somewhere on Saturday morning at 3 a.m. because there was some software issue with the power block. We're a new company. We're still perfecting things. Things are working very well, but that's why we transfer switch. We also use it for testing and upgrades for software. We don't need it like Enphase to kind of transfer between on-grid and off-grid mode, right? That is very much needed by the systems who are grid tied. We are not grid tied, so none of this applies. And then, does Enphase also needs a neutral forming transformer? If everyone on this call just look somewhere else and passes on, but we have neutral forming, transformers on our inverters at this time. So, and since we are the grid to the home, we always have to have a neutral and be defined. So the person who asked that question, you can follow up with us directly for more details. But let's move to another question because it's highly technical. But the answer is, as a grid forming system, we don't have these transfer issues. And we also already using a neutral deriving transformer. So how can you become an installer for the power block, and how soon can you deliver on an order? We have built built the 6 systems, 8 if you count the earlier vintage, and we're currently commissioning 2 more, and then we're going to do the clinic. So please contact us. We are tending to move over to the Power Block 600. That will take us, a few months to adapt our electronics. We think it's highly worth it. It makes the system even better in a very significant way. So contact us. You'll be looking forward to distributors, installers. There will be very little training involved. That's the benefit for you. We stand behind everything. You don't have to worry about when things don't work. We'll take care of it. We'll simply tell you what to do. And usually that just means exchanging a module, because all modules are in parallel. There's really 2 wires coming in, plus minus, and the connection for the communication. So you don't have to figure anything out. Whatever module doesn't work, all modules are parallel. Take it out. We send you a new one, plug it in, and that's the amount of the repair. So please get in touch with us. Thank you for that question. All right, we're coming to the last question here of the call. What changes will you have to implement to support alternative power standards in other countries? Well, that's about the best question I could have received. So bear in mind, we do not connect to the grid. All the regulations regarding grid-tied inverters, intentional islanding, meaning this code in that country, none of those apply. We are a grid forming inverter. The grid comes in through a rectifier, like we showed on a previous presentation, previous webinar, which is just a pretty small device. And all we're looking for are grid forming inverters at 60 or 50 hertz at 240 volt or 230 volt respectively. As it turns out, every single grid forming inverter that we're purchasing right now with a simple software reprogramming, like a setting switch, changes to 230 and 50 hertz. So we can at this point deliver the power block anywhere in the world. The inverters for those are already made. It doesn't matter which country it's going into. It doesn't matter which jurisdiction, what utility, because it has nothing to do with the utility. None of the systems we've built to date or building right now have ever had a conversation with the utility. The utility is not involved in these installations. We have nothing. There's no approval we need for utilities. And similarly, it makes it so much easier for us. Any inverter we have right now in the United States, provided it has certifications for safety that are required in countries, all these inverters have UL certification or CE certification. That's a globally accepted standard. So we can go anywhere right away. We don't have to learn anything about the local utility. You just have to tell us whether 230 volt, 50 hertz, or 240 and 60 hertz. And if you're 3-phase, what kind of phase power you have. So thank you very much for these questions. I want to say that we'll be posting this webinar on our YouTube channel. We'll send all the attendees and all those who register the link to the webinar. I hope this was interesting and interesting to you, and you learned something, and hopefully you agree with us that we have built something extraordinary, something that removes all the limitations that we currently see in Enphase and SolarEdge and other systems. And hopefully you agree that we'll be succeeding those market leaders in the future. Thank you very much. My name is Arnold Leitner. I'm the founder and CEO of YouSolar. We'll see you again at another webinar. Goodbye and have a good day.